and welcome to an algebra tutorial video learning about single variable inequalities. We are going to be talking about graphs of single variable inequalities. So we can represent things with greater than, less than, and greater than or equal to, and less than or equal to. But pictures are just nice. We want to represent all the possible solutions, all the different numbers that can work for the inequality. We just want a picture that shows all the possible values. So we're going to go over some examples. We're going to take 4 different inequalities and show how to actually graph them and their inequalities. All right, let's start with x is greater than negative 2. Okay, so I know thinking about this, it's opening up towards x, so x is greater, and I want all the numbers that are greater than negative 2. Well, if I think on a number line, we get greater as we go to the right. That's where numbers get greater, right? 1, 2, 3, 4, 5. They get bigger and bigger as I go to the right. And they get less as we go to the left. So in terms of a number line, it seems like kind of a no duh, but it's really important to keep that in the back of your mind as you're working on, well, which way do I graph this? How do I show all the numbers that are greater than negative 2? Especially if you're dealing with negative numbers and positive numbers to try to keep things all straight. Okay, but we want all the numbers x is greater than negative 2, which means x is bigger than negative 2, and I want to find all those numbers. So sometimes in thinking about a solution or thinking about a graph just shows all the possible solutions. It's sometimes helpful to think of them. So what are some numbers that are bigger than negative 2? Well, 5 is bigger than negative 2. 10 is bigger than negative 2. 300 is bigger than negative 2, but now I've got some examples to help me think, okay, I should be graphing to the right on this one because I want numbers greater than. Now, what do I do at the negative 2? That's kind of my boundary marker, right? So if x is greater than negative 2, that means I want everything bigger, but it can't equal negative 2. But yet negative 2 is my boundary, so how do I show that? Well, we show that with an open circle. So usually we use points, right? We would plot numbers. Negative 2 is right here. I'm going to do an open circle indicating it's a boundary. That's kind of an important feature, but yet it's not equal to. It's like this hollow empty point, so it doesn't count negative 2, but it does count everything greater than negative 2. And so we go to the right, we make a nice little arrow, so people can see, oh, right there, that graph, 5 is a solution, 3 is a solution, 0 is a solution, negative 1 is a solution, everything up to negative 2, but since it's an open circle, it doesn't count negative 2. Negative 2 is not a solution. All right, let's take a look at another example here. Let's do x is less than 1. So what are all the numbers that are less than 1? 0, negative 1, 2, negative 2, negative 3. So we're going to the left. In this case, my boundary is at 1. So I'm going to go find 1, put an open circle, because it doesn't count 1. It can't equal 1. That's not a solution. But it's all the numbers less than 1. So I'm going to go to the left because that's what's less than. And I make a little arrow, and I can see, yep, negative 1 is a solution, negative 5 is a solution, negative 8 is a solution. Those are all numbers that are smaller than 1. All right, so again, there's 2 examples. We use open circles anytime we're dealing with just greater than or less than. We use an open circle because 1 and negative 2 are not solutions to their respective inequalities. Okay, let's look at a couple other ones here. What if I have x is greater than or equal to 8? All right, so what are all the numbers greater than 8? Well, that's 9, 10, 11, 12, 13. But in this case, x could also equal 8. So I gotta be a little bit different in thinking about how to graph this. I'm gonna find 8, that's my boundary. And I know everything greater than 8 is I'm gonna shade to the right because that's greater than. But what do I do at 8? Well, since it includes the number 8, 8 is a solution, I go ahead and think about it as like, okay, well, I'm graphing all the values greater than 8, and I'm graphing when x equals 8. I have those two things to consider. And when we graph x equals 8, that's just a point. So I make a solid point, fill it in, it's a closed circle, is what we call that. And there's the graph of all the numbers for x that are greater than or equal to 8. All right, let's do one more here. So now let's do x is less than or equal to 3. So I've got all the values less than, so I'm going to the left. That's where things are less than. I'm going to find 3. It can equal 3, so I'm going to make a solid dot at 3 because that's one of the solutions, x equals 3, and x equals all the numbers less than 3. So we go to the left and make a little arrow because it goes on forever and ever. All right, there's graphing single variable inequalities, matching up the inequality that what we see on the left here with a nice picture on the right. The thing you want to distinguish and the thing that trips students up is when do you make an open circle for your graph and when do you make a closed circle. It's really important based on the inequality. So closed circle represents when things are equal. The other thing, and again, keep this in mind, I just say this because I see students mess up, is make sure you know that numbers get less when you go to the left and they get greater when you go to the right. And keep that as in mind whether you make your arrow go to the left or the right for an inequality.